Welcome all the students in our YouTube channel Physics by T C Chauhan Sir. Today we are going to discuss about electric field intensity due to an electric dipole. There are two basic cases, either on the axis or on the equatorial axis. Let us discuss electric field intensity on the axis of dipole. This is supposed to be a dipole having charge minus q and plus q. Separation between charges is 2a. This is center O. This portion will become A and this become A. On the axis, there is an observation point P at distance small r from center. Due to positive charge, electric field is supposed to be even, and due to minus q charge, electric field is supposed to be E2. What about the distances? This distance become r minus A and this distance become r plus A. It's very simple. Now, what about electric field intensity? You know, formula of electric field intensity is kq upon r square. Then what about the electric field intensity due to this? Due to positive charge plus q charge, electric field intensity even will be kq upon r, distance will be r minus a whole square. This is equation number first. Now, what about electric field intensity due to minus q charge? It will be E2 is equal to kq upon r minus a whole square. This is equation number second. Then this is r plus a, sorry. E2 will be r plus a whole square. Now, what about electric field intensity net? Net electric field intensity will be E1 minus E2. Because denominator is less, so E1 is more. Both are opposite because of positive and negative charge. We have to take only magnitude. We need not to take direction. Then E will be equal to, we have to put the value kq upon r minus a whole square minus kq upon r plus a whole square. Now, take the quantity which is common. E is equal to kq, that is taken common. The quantities remain are r minus a whole square minus 1 upon r plus a whole square. These two quantities are there. Kq is taken common. Then E will be equal to, kq is taken common. The LCM will be r square minus a square whole square. Here there will be r plus a whole square minus r minus a whole square. Now, kq, just open these quantities. R square plus a square plus 2ar minus r square minus a square plus 2ar upon r square minus a square whole square. These two quantities will get cancelled. E will be equal to kq into 2ar and 2ar become 4ar upon this quantity A is very less than small r. So a square is neglected. Let us neglect this. Then there will remain r square whole square. Now, this 4 is divided in two parts, 2 into 2, that is 2kq into 2a r upon r to the power 4. This q into 2a become p. This r will get cancelled, rq will be there, and hence the resultant electric field intensity will become E is equal to 2kp upon rq. In vector form, E vector will be 2kp vector upon r cube r cap. This is vector form of electric field intensity. Now, what about the value of electric field intensity in terms of direction? So here, dipole moment and electric field intensity both become in same direction. So P vector and E vector are in same direction. So angle between dipole moment and electric field intensity will be 0. This is about electric field intensity on the axis of dipole. Now we discuss about electric field intensity on equatorial axis of an electric dipole. This is supposed to be an electric dipole plus q and minus q charge. This is center. It is 2a separation, a and a. This is small r, is the distance. It is an equatorial axis. It is observation point P. Due to plus q charge, electric field intensity will be E1. due to minus q charge, electric field intensity will be E2. This angle is supposed to be theta. Since this is r, this is a, so it will be under root of r square plus a square. This also will be under root of r square plus a square. Now, to find resultant electric field intensity, we have to take components, and the components are, this angle is theta, so it will be E1 cos theta. This will be E2 cos theta. Here there will be E1 sin theta, and this component will be E1 sin theta. Now, these two angles are theta also. Now, what about the field intensities? E1 will be kq upon distance. Due to positive charge, the distance is r square plus a square square root. Then it will become r square plus a square only, because square root will get squared. Then it will be E1. E2 will be kq upon r square plus a square. We are taking magnitude, not direction. Then these two are same. It means E1 is equal to E2. When both are same, then we have to find the resultant. These two are same, then vertical components will get cancelled. That is E1 sin theta and E2 sin theta, both will get cancelled. This was E2 sin theta. These two will get cancelled. The resultant will be E will be equal to E1 cos theta plus E2 cos theta. Since E1 is equal to E2, that's why it will become E is equal to 2E1 cos theta. Then what about the values? E will be equal to 2. E1, that you know, kq upon r square plus a square. What about cos theta? In this triangle or this triangle, you can take cos theta base upon hypotenuse. So it will be a upon under root of r square plus a square. Then E will be equal to kq into, this will become 2a upon r square plus a square ki power 3 by 2. It will become r square plus a square to the power 3 by 2. Q into 2a, you know, p. So it will be kp upon r square plus a square to the power 3 by 2. Since a is very small, so it will be neglected. A is less than r. So E will be kp upon r square to the power 3 by 2, since a square is neglected. That's why it will become E is equal to kp upon r cube. This is electric field intensity on equatorial axis of an electric dipole. Now, what about vector form? E vector will be minus kp vector upon r cube r cap. Question arises, why negative sign is there? Why we have taken negative sign here? The reason is, the electric field intensity resultant is in this direction and dipole moment is in this direction. These are opposite. E vector is in this direction and P vector exactly opposite. So angle between them will be 180 degree. These two will be 180 degree. So this is about electric field intensity due to an electric dipole on its equatorial axis. Now we have to find electric field intensity due to any point r comma theta. What about that? Suppose this is an electric dipole, charge is plus q and this charge is minus q. Separation is 2a in between them. You have to find at angle theta and at distance r there is an observation point. Then resultant electric field will be E, making angle alpha with horizon. Then what about the electric field intensity in this case? Electric field intensity at r comma theta will be kp upon r cube. P is dipole moment, square root of 3 cos square theta plus 1, and angle will be tan alpha is equal to tan theta upon 2, or alpha will be equal to tan inverse tan theta upon 2. This is about electric field intensity due to an electric dipole at any point r comma theta other than. The numerical problem will be like if there is a question in which charge is given to you 4 microcoulomb and separation is given to you 1 nanometer, supposed to be, and you have to find electric field intensity due to this dipole at distance 10 centimeter from center. There are two parts, one on axis and other part is on equatorial axis. How to find? Very simple. You know the formula. E axis will be Kp upon R cube, 2 Kp upon R cube. 2 K is 9 into 10 to the power 9. P dipole moment, that is Q into 2A, then 2K into Q into 2A upon R cube. What is charge? That is 4 microcoulomb, 4 into 10 to the minus 6. Separation is 1 nanometer, that is 10 to the minus 9, upon R cube 10 centimeter, that is 0.1 into 0.1 into 0.1. Just solve this. Taken out the points, here it will become 10 to the power 3. It is 72. It is very simple. 9 4s are 36, 36 2s are 72 into 10 to the power. This 10 to the minus 9 and plus 9 will get cancelled, and here it will become 10 to the minus 3 Newton per coulomb. This is on the axis. Another is on the equatorial axis. E equatorial will be Kp upon R cube. It is just half of E axis. So E axis result is in front of you. Just put its value. You will have 36 into 10 to the power minus 3 Newton per coulomb or volt per meter. It can be converted into scientific notation like 7.2 into 10 to the power minus 2 Newton per coulomb, or it can be written as 3.6 into 10 to the power minus 2 Newton per coulomb. This is numerical base depending upon the electric field intensity. Sometimes the angle can be asked. Sometimes theta is given to you, displacement is given to you. What is to find? Just put the value of theta and get the result. Like dipole moment is given, displacement is given, theta is given, then you can put the values and get the result. I think you have taken the benefit of this video. Please do subscribe, share and like our YouTube channel, Physics by T C Chauhan Sir. Thank you very much.